talking about Cloud Native in an hour or 40 minutes, which is going to be a demonstration of Spring Cloud with Consul and Resilience4J. So this is exciting times. We've got that all queued up. There it is, Tola, Awofolu. And here we go.
Well, hello, everyone. I'm Tola, Awofolu, and I'm going to be doing a talk about Spring Cloud. This is basically an intro-level discussion about Spring Cloud. So if you're new to Spring Cloud, you've come to the right place. The goal of this presentation is to give you a practical demonstration of how you can use some of the latest and greatest modules from the Spring Cloud ecosystem to develop cloud-native apps for today. So in the next hour, we're going to be live coding a simple real-life app using microservice patterns. So here's what the app looks like right now, and I'll show that to you right here. So here we've got what I'll call a voting dashboard, and it's basically a dashboard that aggregates data from two voting squads, a red voting squad and a blue voting squad. So it aggregates voting data from the red squad, voting data from the blue squad, it aggregates it together and displays it in a visualization. Now, as you can see here, there is no data right now powering this dashboard. What we're going to do is build the back-end microservices for this dashboard. So let's take a look at the architecture for our system, and I'll bring up a quick overview here. So we got our UI, and the UI is going to subscribe to a stream of events emitted by our gateway service, which will be our API gateway, or the entry point into the system. This API gateway service will route to either the blue service or the red service by matching on a set of predefined predicates. In turn, the blue and red services will invoke a random number generator API, and it will use that to generate random voting data for the app. It'll use Consul for service discovery, Spring Cloud Load Balancer for client-side load balancing, and Spring Cloud with Resilience4J for circuit breaking. Now, a quick overview of what those terms mean. Service discovery, and by extension, service registration, is one of the design patterns that are required in a distributed environment. And it's just an acknowledgement of the fact that you can't assume that you can locate services by their physical address, because you're dealing with a dynamic environment now where service addresses can change at any moment's notice. So instead, you rely on some kind of virtualized addressing scheme to locate services. This virtualized addressing scheme, or logical addressing scheme, will then be responsible for translating between the logical address and the actual physical address of the service. With service discovery, services are registered in a service registry, which can then be queried later for locating their network addresses. You also got client-side load balancing, and if you take a look at the prefix LB here, that protocol tells API Gateway to use a load balancing enabled client to access the service. So it usually works with service discovery, and it allows load balancing decisions to be made on the client side and not just on the server side. There's several benefits to this. It eliminates single point of failure with server-side load balancers. It's easier to tailor load balancing decisions to the client, easier to automate dynamic changes at runtime, reduced network hops, and so on. You also got the API Gateway pattern, and the API Gateway is the entry point for your system, kind of like the front door of a building with multiple rooms. So it decouples the underlying microservices and their architecture from the outside world. And it can be used to consolidate cross-cutting concerns like security policy, access policy, content validation, traffic management, monitoring, metrics, and so on. You also have the circuit breaker pattern for fault tolerance and resilience. And there are several other resilience patterns like retry, time limiting, rate limiting, bulkheading. But here we're going to focus on circuit breaking. And with circuit breaking, services are wrapped in a monitor. When service calls fail, they're automatically redirected to a fallback API for a pre-configured window of time or a pre-configured number of calls. After this sliding window passes, if the service is healed, then its state is restored to normal. Otherwise, it continues to be redirected to the fallback. You also got other patterns: distributed tracing, centralized configuration, intelligent routing, distributed messaging, and so on and so on. So we'll be live coding our system to support some of these patterns during the course of this hour. So now let's go ahead and get started. So the first thing we want to do is we want to start up our console server for service discovery. So we want to start our console agent in server mode, so server true. We want it to be a bootstrap server, so bootstrap true. We want to start up our console UI. We want to be able to connect to the agent from anywhere. I'm going to bind it to my private IP here. I'm going to link it to this temp directory for console configuration. And with that, we should be able to start it up in the background. So let's go ahead and verify that, and looks good. So let's go to our browser and launch the console UI from there. And we can see that the console service registered itself here and the console UI is up and running. So it looks good. So next, we're going to go ahead and create our red microservice. That's going to be the service that handles generating voting data for the red voting squad and sending that to our dashboard UI. So to do that, let's go to the Spring Initializer website. Let's start.spring.io. Let's create our app. Let's say workshop. Let's call it a red service. Let's include all the dependencies we need. So we're going to need a dependency to allow us to communicate with the console discovery server. So let's incorporate the console discovery client. We're going to want to do reactive APIs. So let's include Spring Webflux. We're going to want to include the latest iteration of the Spring Cloud Load Balancer. So let's include that, and we're going to use that instead of ribbon. Let's include the actuator module so we can expose endpoints for gathering metrics and events. And let's include a couple of utilities. So we'll include Lombok for boilerplate code. We'll include the DevTools library for live reloads. And with that, we should be good to go. So let's generate our app. And let's import it into our workspace. So import, and let's get our app. So cool. So next, we're going to leverage auto configuration here. So thanks to Spring Boot's auto configuration, we're going to be able to enable several core features without having to write a lot of code. Instead, just by virtue of having the right dependencies in the class path, which we just took care of, and by including the right properties in our config, we're going to be able to have Spring wire up different essential components and add it to the Spring context for us. So let's go ahead and make some changes to our application config. I'm going to use YAML. You don't have to use YAML, but I just like YAML, so we'll use YAML here. So let's give our application a name. So we'll say Spring application.name. Let's call it red service. We want to make sure that each instance of our server is uniquely identified by console. So we'll say spring.console discovery instance ID, and we'll give it a unique identifier. So we'll use the prefix that matches our application name. So just copy that. And for our suffix, we'll use a randomly generated token. So this Spring EL expression is just utilizing the random property source, and that's an implementation of the property source that uses as its underlying object the Java pseudo-random class, Java util random, and it basically generates random strings for you. So it's pretty nifty. We'll use dynamic ports so that we can easily stand up multiple instances of our service. So we'll say server.port is 0. We'll disable ribbon. So we'll say spring.ribbon enabled is false. We'll expose all of our actuator endpoints for now. So we'll say management.include HTTP endpoints. Will include all of our endpoints. Obviously, in real life, you're going to want to use some access control for accessing these endpoints, and you're not going to want to expose all of them. But for our purposes, it's fine. And with that, we should be ready to fire up our red service. So let's go ahead and do that. Great, so our red service is started. So let's go to our browser again. And we can see that the red service registered itself. So that's good. And let's actually start up another instance of our red service. Once we do that, that should also register itself, and we should see it in console. So indeed, we see that there are now 2 instances of our red service with dynamically allocated ports. So wonderful, that's great. So let's stop that second instance for now. Next, we're going to write some code, and what we want to do is leverage the discovery client, which is automatically wired up for us via the discovery client dependency that we've injected into the class path. So what we want to do is we want to write an API that will leverage the discovery client and use it to locate all the available service instances. So let's create a controller, and we will create a REST controller. Let's create a controller class here. And let's go ahead and inject our discovery client. So we'll say auto-wired discovery client. And let's create our API. So we'll say we want to return all of the instances. And we're gonna, in order to do that, we're going to return discovery client dot get all the services. So first we're going to get all the available services. Then let's stream that. So let's stream. Then let's do a map, and we're going to map each service that we locate here to all of the instances associated with that service. So we're going to say discovery client dot get instances, and then we're going to apply our mutable reduction and collect all of those instances into a list. So we'll say collect, and we'll say collectors to list. So that looks fair. So let's register that API. So we'll make it a get resource. So we'll say get mapping, and the path will just be instances. So that looks good. So let's go back to our browser. And if we go to our red service, we see that it's been allocated port 53128. So let's go to localhost 53128/instances. And we can see that we've got
Hey,
some data
everybody, just to
coming
let you know,
back
we are
for
working on the
each of our
small text
instances.
issue. Obviously, this is something we didn't foresee with the video, playing, streaming live. So please be patient with us. We're trying to figure it out as we're going. Hey, it's all happening. Anyway, thank you so much for your patience.
And actually, we should go to Firefox for this because Firefox has a nice JSON viewer. So let's go to Firefox and let's locate. And now you can see the services and all of the instances. We have our red service and it's prefixed with the app name and suffixed with our random token. So that looks good. So next, what we should do is we should write the logic for generating random data. So let's create a separate microservice that will actually generate random numbers. For that, we'll go back to Spring Initializer. Let's create another app. Let's call it Vote Generator. And we can use the same dependencies that we just used for the red service. So let's generate that. And let's go ahead and import that into our workspace. So import vote generator. Great. So now let's go ahead and make some of the same config changes that we made for our red service. So let's give our app a name and let's call it vote generator. Let's make sure that Consul is able to uniquely identify service instances. So we'll say Spring Consul Discovery Instance ID, and we'll give it the application name as the suffix and the random token as the, or I should say the app name is the prefix and the random value is the suffix. Let's disable ribbon. So we'll say Spring ribbon enabled is false. Let's use dynamic ports. So we'll say server.port is 0. Let's expose the actuator endpoints for HTTP. So we'll say management.port